All right, so this video is going to cover ice and water shield and how we introduce the system. So this will be the transition from your prep work into the total protection system, and then as well, ice and water and the difference between the good and the bad. All right, so what happens here on roofing today is it's no longer just shingles, as we discussed earlier. There's a complete system that all works together to make sure that no water gets inside of your home. Now, with that being said, it's a three-part system. Some components seal everything down, other components defend or shed water, and last but not least, other components are designed to keep the humidity level down in your home and the heat level lower by exhausting out excessive heat and moisture from your attic, okay? So seal, defend, breathe. So let's get into the first component used to seal. So remember, when it comes to keeping water out, it's a two-part system. Part one is shingles, which shed water. Part two is underlayments that waterproof.
Yes.
Understand on a roof today. Let me see that GAF shingle for an example. No, you're good. Right there. See, years ago, they tried to make these shingles with a continuous sealant line going all the way across. And then you know what happened to them?
Fried.
They cook from the inside out. And here's why. Imagine a pressure cooker where that lid is locked tight. It allows everything to get to its hottest temperature. Okay?
Yes.
The minute you turn that valve, the steam goes, it shoots right out. Okay?
Yes.
When you take a lid off of a pot of boiling water, what happens to the boil? Comes down.
Comes down. Yes.
Right, it calms down because that expels that heat. These shingles, compared to a traditional shingle, which is a three-tab was just made of asphalt. Asphalt's what the street's made out of.
Yes.
The street can get as hot as you want. It's still going to be there. Not going to hurt anything. The problem is asphalt's weak and it does crack.
Fried. Yes.
How often are they repairing the roads?
Every day.
All the time, right? So now, with that being said, the roofing manufacturers realize with asphalt, the highest they could go for a wind pressure rating is 60 miles an hour. And that's the max. So, over 30 years ago, Owens Corning, what they did was they developed a technology to create a fiberglass mat in the asphalt shingle, completely changing the industry. So now, what happens is there's actually fiberglass, you can see the fibers here, woven and integrated into that asphalt, reinforcing it. So imagine, think of like rebar on a concrete building.
Mm-hmm.
That's the fiberglass to the asphalt on your shingle, okay? So with that being said, fiberglass has a different temperature threshold. They cannot get as hot as just asphalt, right? So because of that, they have gaps in the sealant. So there was a couple huge class action lawsuits for shingles blistering. They were just cooking from the inside out. So once those lawsuits were settled, they realized they had to change manufacturing, and they needed gaps where heat can expel out, right? So it can cool off a little bit. So this is why roofing is a two-part system now. Because of these gaps, if I get a heavy wind and wind-driven rain that's kind of going sideways, you think water might pass through there?
Of course.
Of course it will. So whatever is underneath of the shingle to catch that water is going to make the determination whether it goes in your house or it stays on the outside, right? Follow me so far?
Yes, sir.
All right, fantastic. So the benefit of that, though, okay, well, why would they do all that where you need all this extra stuff to seal? Here's why. Because now, instead of 60 miles an hour, these shingles go up to 130 before you even need to involve your insurance company. That's amazing, isn't it?
Yes, sir.
I mean, that's a lot of wind, okay?
Absolutely.
So I'd rather do it this way and then be fully protected. Just put the right things underneath. All right, so let's get to your ice and water for a second. So with the ice and water shield, ice and water is a self-sealing membrane. So almost think of it like a puncture sealing product or like a run flat tire, okay? Where you can't get it flat, just the common principle. So what ice and water shield has the capability of doing is when a nail punctures through, okay, it actually self-heals around the nail. So let's just say we made a fish tank. At the bottom of that fish tank was ice and water shield. And we put 100 nails in it. And we filled it up with water. To become ice and water, no water can drip through. Make sense?
Yes.
All right. So unlock this real quick. So this is where you're going to use the slide with the illustration of the nail going through the ice and water and then also the visual of the ice dam. Oh boy. What did I just do? Okay, so this illustration right here. So on this side, what it does is puts a visual in their head of an ice dam and shows how the water backs up. So an ice dam basically forms, and then that water is trying to drain, but it has to rise 2 to 3 to 4 inches to spill over
the ice.
that snow before it can actually drain, right? So gravity's pulling it down, but the snow's blocking it, thus creating a dam. So that pooling water backs up and goes between those gaps in your shingle and gets down to the paper. Make sense? Okay. So with that being said, ice and water shield has to go anywhere where there could be a potential of pooling water or a very high risk of leaks under the shingle.
Yes.
Okay? Those areas are your eaves, your valleys, and any penetration points. So, Uma, can you explain to me what an eave is? Are you familiar with what an eave means on a roof or no?
I am.
Play stupid, you're my customer. So
No, I don't.
you don't know? Okay.
No.
So take a look at this illustration right here. So what an eave is anywhere you have a gutter,
Okay.
right? It's where the water comes down to the bottom,
Yes, sir.
right? So the way the roll is the roll's designed in a 39-inch roll, and it's going to laminate and peel and stick to the wood. So it basically bonds to the surface, kind of melts into the wood, creating a top layer or laminate on the wood in these areas. So with that being said, when they laminate it down, it has to go minimum 39 inches up or 24 inches in past the warm wall, which is your exterior walls of your home. Okay? So super, super important it goes there because that's going to catch all that pooling water from your ice dams. Second place is a valley. A valley is when two sections of the roof come down to a low point. Okay? Valleys are super important to have ice and water, are super important to have in a valley because that's a low point. The lower it is, or the closer it is to your attic floor, the closer it is to heat escaping from your home. So the belly of that wood is warming because it's a warmer temperature. The lower you get in your attic, it's melting the snow faster.
Yes, sir.
And it's creating ice dams. Okay? Make sense so far?
Yes.
All right, and then last but not least, penetration points, which is going to be your chimney, pipes, attic fan, anything sticking through the decking of the roof, you must have ice and water shield because they're a very high risk for leaks. Okay? So let's get into the two types of ice and water. I'm going to pass them over here. So, ice and water comes in either a granular surface or what's called a mat. Mat is an Owens Corning exclusive. We're going to get into that in a second. With the mat, this is something that is just absolutely amazing, and I'm going to discuss with you what it's capable of. But let's start with the G so you understand why this is even valuable. Okay? So take a look first, feel the product so you can see what it feels like. Okay, rough granular surface, nice peel and stick on the back. Very, very sticky, right? So when you peel this up, you can feel here, feel how sticky that is. And this is cold right now.
Oh, yes.
Imagine when that gets hot.
Yes, sir.
And it's going to peel, stick, and laminate down to the wood, okay? But here's the challenge. That material is that sticky all the way through. So on the back, they can put the peel and stick tape, right? So you can just peel and then laminate down. But this is sold by the roll. In order to roll this product, the top cannot be sticky, right? Otherwise, it would just stick to itself and you'd never be able to open it up, right?
Yes.
Make sense?
Yes.
So it's like double-sided tape where they always have to put the paper so you can actually peel it off and use the product. So with that issue, what they found was the most cost-effective way to seal the top where it's not sticky anymore is just to crush roofing granules and press them in. So they compact it with so many granules that it's no longer sticky on the top because they get embedded in that sticky sealant. Making sense so far?
Yes, sir.
All right. Now let me ask you a question. Everything is held down by nails and sealant on a roof, okay? If I seal down, sealant is a lot like tape. Would you agree?
Yes.
All right, so if I seal down on this granular surface, okay, and then we go back to that illustration where the water is pooling behind, getting under the shingle. When that water gets underneath of the shingle, as you can see here, it freezes. When water freezes to ice, it expands. And when that expands, let me see the shingle for a second. what's gonna happen is it's temporarily gonna delaminate or lift off of the ice and water. That sticky sealant is gonna be caked in with those little granules, right?
All the time, yes, sir.
Then the snow and ice is gonna melt, it's gonna have sun baking on it, it's gonna lay and bond back down again. Every winter, this is gonna happen several times, okay? Every year, over and over again. Eventually, every time it lifts up and down, there's more and more of those granules getting stuck to it and dirt and other things because it's backing up snow.
Yes.
What do you think happens to the effectiveness of that sealant over time?
It's not gonna be effective as first.
Of course, it's like having a piece of tape that's dirty,
Yes.
right? It just sticks a little and then falls off. So then eventually, in these severe zones where you need to seal the most, what happens on these shingles is now they're only being held down by gravity, by their own weight. So when you have a windstorm, they just lift and then allow water infiltration to come in. Okay? Then it gets hot and they lay back down again. See, we found out about it because we used to use the granule
Mm-hmm.
and we started to have service issues with this product. So we actually met with our team at Owens Corning and we said, listen, we need a solution where we can guarantee, because we're in the Northeast right here, we can guarantee we're not going to run into this issue any further, because what am I going to tell a customer? I didn't make the product, right?
Mm-hmm.
So what they did was they actually introduced us to a product called Matte. Weatherlock Matte is a phenomenal product. You're going to feel it. Feel how thick that one is. It's actually beefier
Oh yeah, definitely.
than the granule. Okay?
Yes.
Here's why. This one actually matches the life of the shingle. Okay? A lot of underlayments people don't understand are not 50-year. So just because everybody today says you're going to get a 50-year shingle does not mean that what's designed to catch water also lasts 50 years. No. Okay? So this is actually a true lifetime underlayment. It will be there always, no matter what. Okay? Where those granular surface ones, they range in warranty anywhere from 10 to 20 years max. And that's it. So, with that being said, not only will this be there forever, more importantly, feel the surface on the top. What do you notice that's not there?
Granules.
No granules, right? Reason for that is when that sealant lays and bonds down to this material, it is chemically engineered to create and fuse together and create what's called a monolithic bond. With that monolithic bond, all these materials become one and completely inseparable. Okay? Thus, allowing us to eliminate any service calls in the future. So with that being said, Umit, between these two materials, which one would you feel more comfortable with on your home?
Matte.
No. I mean, would you allow me to put that one on at any price?
No.
No, right? Fair enough. All right, so this is the one we're going to use on your project. Okay? Great.